So here we are at lesson 12, volcanic hazards. In this particular one, we're moving forwards from looking where we looked at a couple of case studies, both based in the Philippines, although your school may well have done something different. And before that, looking at the theory of volcanoes, the types, the size, the magnitude of them, and the types of hazards that you get with them. This video is concerned with looking at the management of them. So, just examining this a little bit more here. So this is the area that we're concentrating. I did it slightly out of sequence in comparison to the way that I did the case studies, but I wanted to isolate this so it's a bit more specific. So what we're looking here is the response. Now, when you look at Mount Pinatubo or other volcanic case studies you've done, you'll often look at the short-term and long-term responses, and that pervades through all the case studies, whether it's tropical storms, volcanic eruptions, earthquakes, fires in nature, that types of thing. What I'm going to look more here is there something we can do about volcanoes, right? And often a question is, is managing the impacts of a volcanic hazard easier or harder than, say, against a tropical storm or tsunami or earthquake, etc. So you've got that judgment that can surface in a 9 marker or a 20 marker. Okay, so you need to know the stuff, but then you've got to be able to weigh it up, and that's where your case studies come into it and your thought patterns. So what we'll look at here is the what can you do? And in doing so, we've got the key areas. How do we prepare, mitigate, prevention possibly, and adaptation, something like that. So that's the bit that I'll focus on today, not on the impacts of it. So if we look at the preparedness bit, this is going to include things like, what you've got in place, monitoring, how that monitoring then influences what you do in and around the volcano. And I would say this is where volcanoes have one up on earthquakes, in the sense of where there's a volcano. Whereas with an earthquake, it's on a plate boundary, fault line on a plate boundary, over 1,000 kilometers long. And it's very difficult to say where it's going to trigger off. You might get 30 seconds pre-warning. Here, there's a volcano very often in a very precise point, so it's there. There's been some past maybe eruptions, so you've got evidence. There's geology understood about it, not seismology, the volcanology of it, and you understand the nature of the types of threats. So you have this like background, the science that kind of goes with that. But on top of that, if you know where it is, there is technology that then you can use to monitor it, and then maybe get days, weeks, maybe even several months prior warning that that volcano will erupt. And this has been successfully done. So more recently, this is 2024, and it was winter of 23, Iceland, they predicted that volcano was going to erupt in the south of the island. They evacuated loads of people, and lo and behold, it erupted. So how do we do that? Well, there's a number of things. You can use photography, where you're using time-lapse photography, you're using lasers, and you're measuring um, whether the ground is bulging, and you can see that over time lapse. So you can make that measurement and the size of that, where it's happening, the rate of that, and therefore that you'd use that to say, well, it looks like the magma chamber's really enlarging. It could erupt. But you wouldn't use that information on its own. You'd use other information too. On top of that, you might have like gas readings within water nearby, in the soil, in the air, and they may detect things like sulfur dioxide, carbon dioxide, and you can read some of these things on the slide that I've got in front. And other things would be micro earthquakes taking place, and even things like animal behavior, and you always see in those films where animals are like running away and they go, oh my gosh, what's going on? Something crazy's happening here. But a combination of all those things, they can add up to giving you a fairly good prediction. I've heard, for example, Vesuvius, which is seen as one of the more dangerous, if not, I don't think it's the most dangerous, but a dangerous volcano waiting to erupt, having maybe up to 2 weeks, months of advanced warning. Whether how true that is, how accurate that is, but you've got millions of people living near the slopes of that, so you do need to have a good gauge of when it could possibly erupt. And what that monitoring allows you to do is to make reasonably good predictions, and therefore things like you can evacuate people well in advance, get people out of harm's way. And that has been done successfully. You can't do that with earthquakes. I mean, earthquakes, you might be in earthquake territory. You might know we haven't had a big one for 50 to 100 years. That makes it more likely in the future. You just don't get that. You can't evacuate immediately from an earthquake. You can take cover. You can evacuate from the aftermath of the earthquake, get people out of the area to camps and things like that. But this one you can. You can get people out of harm's way, and other things that you can do risk mapping, which is what we've got here. So you do everything from looking at like the geology, the soil, the hydrology, weather patterns and things like that. And you go, well, this time of year in this place, this is more likely to have landslides, mud flow risk, liquefaction, if that did actually happen. There's a lake that this could be the impact of a tsunami caused by an eruption. So you can model a lot of this stuff. So you'd have the risk mapping, but then you can also do hazard mapping. So within that, obviously, the risk areas, and again, with the other combination of factors, you can then say, okay, we'll only allow this and this to take place in that area. And you see this in things like flood management, and coastal management, and things like that. So you might go, it's not suitable to have high levels of population. It's too near the volcano. The ground may be too loose and unconsolidated. It's too steep, and there isn't a quick evacuation out of that area. So therefore, you can inform it and determine. So that might be restricting who lives there, how many live there, and the activities they do. But also, that would enact if we think that if we think that volcano is going to erupt, we need to get those people out first. So you can do it in steps. And I believe with the Vesuvius, they got some action like that, where they would evacuate some people first, in a particular order. That doesn't mean to say it's infallible, because we do get volcanoes that take place where people have been caught totally unawares. And I'm sure that will happen in the future. But I would say it's more successful than with earthquakes, not just more, just significantly more. And also, again, that could lead into the mitigation side of things, where you say, well, we need to have extra strong roofs because the ash could cause them to collapse and things like that. We might, like where they've got in Japan, you might have a few like reinforced huts, so tourists, if there is ash fallout, at least they can take some temporary cover. And there may be even things like communication lines that allow people to get access. Help, 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 I'm up here. And so they're informed, and then at an appropriate time, they can be rescued. Now, in terms of mitigation, you're mitigating the effects like most of these things. You're talking about mitigating, reducing, stopping the impacts. This is where I'd say earthquakes really have a one-up on volcanoes. I would say there's less you can do to mitigate. So I've said, for example, you live in a volcanic area which is likely to have an eruption at some point in the future. You can have buildings with like extra strong roofs. Okay, so they can withstand extra ashfall. You can have, let's say, huts and reinforced buildings where maybe they give you some temporary protection. But when you're dealing with things like pyroclastic flow, mud flows or lahars, significant ash, lava, everything like that, that's sometimes it's overwhelming, and there's very little you can do about that. Have been some mitigation strategies done with some success. So if I concentrate on the, where is it here? There was the Etna. There we go. 92, 93, something along the lines of that. And there was some success where what they did is they dug channels that dropped concrete blocks, and in some instances used explosives to move soil, earth, rock, and stuff like that. And the idea is to redirect some of the lava. So if the lava is moving slow enough, you can maybe change the direction. But, and this also occurs with the 1973 Iceland Hymenea, when you can see in the second bullet point. I've got that more on the next slide, so I'll talk more about that later. If you've got a continuous flow of lava, like huge quantities, a bit like, you build a pretend sea defense out of sand, and the tide's coming in, and you, with your family, you try to say, "Look, guys, let's keep the walls up, let's keep the walls up." Yeah, you might have like an hour of maybe holding back the water, but eventually the tide comes in and overwhelms the defences, so you're a little bit limited. The 2024 eruption, the Fisher eruption in Iceland, they built huge embankments where I'm more talking about the third point around the geothermal power station, and I think around the town as well. I read somewhere really high, about 15 plus meters around the geothermal station, with the idea that they'll keep the lava flow out. I mean, so far so good, but I'm not sure if that's actually been under threat. The problem is, again, it can be overwhelmed. And they've said here, like in parts of Hawaii, barriers have been built across valleys to redirect the lava flow, or lahars, which is a mud flow. 1973, the high moon. I'll come on to that in a second. Really, probably the best thing to do here is go back to what I originally said with the preparedness, with the monitoring, and I suppose the forecasting that comes from that. Get people out, evacuate people. And although with the Philippine Pinatubo eruption in 91, several hundred people, 800 people died, the context of just how many people, hundreds of thousands of people could have been at risk. Mayon, luckily no one died in that one. And you have to say that the monitoring of that and the action taken that seriously reduced the numbers of deaths. And again, the same thing with Montserrat, which is a Caribbean island, and that was a pretty severe eruption. So if we look at this one here, there are some really good video YouTube clips on a lot of these things, but I haven't embedded these in here. So Hymeni is one of the islands off Iceland. It's a fishing sort of port. It's based completely around that, not a particularly large community. 1973, an eruption took place. You've got some details here. And so, what happens is with this eruption, there was lava, there was tephra, some of the buildings were burnt, destroyed. And the very heart of the port, which you can see in the photograph here, was threatened by a lava flow. And if that lava flow went into the bay, it filled part of it in, block it off, and you might argue that that's it, it's over, because the port is the key reason why it's there. And so what they did was they had the boats in the bay, and they were firing these huge like hoses, like fireman hoses, I suppose, water cannons, I suspect, and they pulled seawater 24/7 every day. I don't for many many days, and they pumped it onto one side of the lava flow, chilling it, cooling it, hardening it, and then redirecting the lava. So in that instance, you'd say, yeah, that worked. And if you just look at the figure here, 30 kilometers of pipe, that's just an incredible figure to think about. 6 million cubic meters of water, and they said it saved the port, and therefore the residents returned and they the rebuilt the town. And here you can see the hoses spraying water onto that lava, and in that instance it worked. Here, this is that one I was talking about here, again, just to kind of reinsert this into your head. Building channels, building barriers, using using explosives to create these ditches. And again, if you've got the money, the technology, it might be successful where the lava is limited. Things like pyroclastic flows and explosions and so forth, really difficult. Doing things like, and I'll come on to this one, trying to prevent them is it's just like at the moment, and I can't really see this happening in the future. I think it's impossible to prevent them. So there we go. Look, there's no way to prevent a volcanic eruption. We can reduce the impacts, and I would say key things at monitoring and evacuation. I've seen some outlandish things. Apparently, NASA, I think they did some research with the supervolcano Yellowstone about maybe being able to drill into it in some way to release the pressure, but they came to the conclusion, A, technologically too difficult, too expensive. Do you really need to do that? And finally, also probably think it made it worse. You can't like just pop the volcano. You can't lance it. You can't bomb it. And certainly can't put you well. You just can't do these things on the scale. And even if you could pour enough water onto a volcano, you can't put them out. You probably could create what we call a phreatic eruption, where it just turns to violent steam, which is explosive. Adaptation. If we look at this one here, move away. All right, or and build your land uses and your activities around the volcano. So in some instances, things like it would be when I was in Costa Rica, the Arenal volcano, lots of hot springs, where you could go and bathe in these swimming pools. You create tourism around it. You're going to get the farming around it, electricity, geothermal electricity. all these sorts of things. The microclimate creates, and you live with it, you get lots of benefits with it, but then learn to react, get out of the way of it if you think there's going to be an issue. So that's basically that video. Nice short one there for you to do and create some notes on. I'll post this video a bit later. After this video, we're then moving on to earthquakes. So that's the next theme, or seismology or seismicity. And in that one, we go to the science of it. And again, we go through a case study. I'll probably do 2 case studies, and I'll link it into tsunamis because then we can look at a global impact as well. Okay, thanks for listening. Speak to you soon.